All right, so this is period 4 on April 25th, 2014. This is an experiment of recording live pre-calculus. Everybody in this room has been told that they are being recorded right now, and I'm going to give them their opportunity to voice their protests at this moment. Go ahead, class.
Ms. Paterno, I love you. Hi, Mom.
Anybody object? Does anybody object to being recorded?
I do.
Ms. Paterno agreed that she would give us an alternate assessment grade.
All right, now I'm going to plug my mic in.
I don't want to be recorded.
All right, can you hear me now? All right, it's hearing me. Okay, so here what we're doing is we're looking for all of the values of t, all of the angles that will give you 1 for a sine curve. I've noted them on the curve with these red dots. Okay, dot, 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 dot. Now in my video, in order for you to see them, I have to actually touch the screen. There you go. Dot, 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 dot. Those are all of the places where the sine is equal to 1. All right, what do you think, or actually you know from yesterday, what would be this t value right here where sine is equal to 1? Pi over 2. Very nice. Okay. How about this one right here? That's not 3 pi over 2. Right here is 3 pi over 2. What's that one?
7 pi over 2.
How about 5 pi over 2? Okay, then right here is 7 pi over 2.
9 pi over 2.
So this one is
9 pi over 2.
9 pi over 2. Very nice. So right here I've got negative pi over 2. And over here I've got negative 3 pi over 2.
You put 9 pi over 9.
9 pi over 2. Very nice. Over here I've got negative 5 pi over 2. Here I've got negative 7 pi over 2. So the ones that make sine equal to 1 are these. Okay. So we want to be able to state all of them, and then it's going to continue. Every 2 pi, there's another one. Anybody want to take a guess as to how you can state? Well, first of all, what's the one in the first cycle? In one cycle, there's only one where it happens in the first cycle. Tell me, Selena. Pi over 2. Very nice. And then every what, it happens again. And how long is a cycle? 2 pi. All right. So if I were to, there's that, which we already discussed. So I've got an arithmetic sequence where the first one occurs at pi over 2, and the common difference is 2 pi. Okay. So again, if this is happening over and over and over again every 2 pi, we've got an arithmetic sequence of pi over 2 plus or minus 2k pi, where k must be an integer. All right, I'm going to pause this video so that you guys can get all of this in your notes. Okay, so here's our next problem. All right, the same thing, except now we're looking for where the sine is equal to 0. All right, so somebody name for me an x value or a t value where sine of t equals 0. Name me one of them. Pi. Excellent. What's the next one? 2 pi? 3 pi?
4 pi.
And didn't I say this yesterday when we were graphing this? That we've got a 0 at every multiple of pi.
You did say that yesterday. I remember that.
Okay. So we should be able to very easily write an arithmetic sequence for this. And by the way, you will be asked to do this on your next quiz. You're going to have to write the arithmetic sequence for where all of the values for t that make sine of t equal 0. All right, so what's the first one that occurs in the first cycle? What's the first 0? Pi. Okay? And then it happens, so here is my use of 1. And then it happens every what?
Every loop.
Every pi more, okay? So the common difference is pi. And I think that in order for me to write this arithmetic sequence, I'm actually going to go backwards to my use of 0. Which one didn't we talk about before? There is a 0 at 0. All right, so here's what I'm going to do. My arithmetic sequence is 0 plus or minus pi k, or simply plus or minus pi k. I'm going to pause the video again, let you guys write this down. Okay, next problem. This one's a hard one. Ready?
But you stopped rolling.
State all the values for which sine of t equals 1/2.
How old are we?
So I'm going to draw red dots on the graph whenever I've got 1/2. You see where my 0.5 is on the y-axis? So I've got 1 point here, 1 point here. And then I've got a break. I've got a break for all of this time because here the graph is going underneath. It's going to the negative values in that part right there. Then I've got 2 more that are close to each other. And then I've got a break in between. Okay? And the same thing is happening to the left of the y-axis. So this one's a little bit harder to write an arithmetic sequence for because you've got 2 close together and then you've got that break happening. However, the difference between this point and this point is always a constant. What's the constant between this point and this point? 2 pi, great! And what's the constant between this point and this point? 2 pi, excellent. 2 pi, 2 pi, excellent. So what we're going to do is we're going to write 2 arithmetic sequences. Okay? So the first one here, this is not at pi over 2. Pi over 2 is the maximum. It's half of pi over 2. It's pi, no it's not. Where's that goofy trig card? I'm going to get my goofy trig card. Yeah, I'm being recorded right now, so I can't call it anything else than goofy. Where's my goofy trig card? Who has a trig card you can pull out for me?
I have mine right here.
Great, pull it out.
I pulled it out.
And tell me where sine is equal to 1/2. I almost said it was pi over 4, but it's not.
Pi over 6.
Pi over 6. All right.
You're going to have to edit this out.
No, I'll just put it up like this. Okay, so I've got pi over 6. That's the first one. And we've already said that that's going to happen again every 2 pi. So this is plus and minus 2 pi. Now, how about the next one? Let me tell you where the next one occurs. Selena, you have your, this is pi over 6 right here. Selena, you still have your trig card out?
Yeah.
Okay. So, now, in which 2 quadrants is sine positive? First and second. So we have another angle over here in quadrant 2 where the reference angle is pi over 6. Okay? What is the value of that quadrant 2 angle whose reference angle is pi over 6?
Wait, are you asking me?
Anybody.
Oh, what's the question?
What is the value of this blue angle that's in quadrant 2 whose reference angle is pi over 6? That would be pi subtract pi over 6. So that quadrant 2 angle is 5 pi over 6. And again, that's going to happen every 2 pi. So here we have 5 pi over 6 plus or minus 2 pi. And here is your final answer. If I was really mean, I would give you a question like this on a quiz or a test, which I might. All right, I'm ending the recording. I'll probably post this on YouTube.
Really?
Yeah.